And I mean that. You talk about something that is in Common Core, it's factoring. Hold on a minute. You got to figure out how to arrange my desktop here. All right. So the first one is just a second. Something's wrong with my drawing program. Okay. Now I'm ready. So we got x squared minus 4x minus 12. If there is one skill that you absolutely need, whether it's for the MPE or SAT or ACT or just any old algebra class, it's factoring. We'll see how good you are, and if you're not very good, I'll show you how I do it. They may have actually taught you a different method than the one I use. There's lots of methods for factoring, and I choose to use the one that to me is the least complicated, the easiest to understand, and so forth.
Okay.
But I'll let you use whatever method you know how to use. Do you know how to factor this expression?
Yeah.
What is it?
It'd be x on both sides. X plus 3. Wait, hold on.
We need factors of 12 that subtract to 4. What are factors of 12 that subtract to 4?
3, right?
No.
Or just
They got it. Both numbers have to multiply to 12. When I say factors of 12, that's what I mean. Is what two numbers multiply to 12 and subtract to 4? Well, let's look at all the factors of 12, starting with that one. Next one is that one. Next one is that one. That's the one we're looking for right there, that pair. See why?
So it'd be x plus 2, x minus 6.
No, yes. In other words, you take, once you found your factors, then you put the larger of the factor, 6, with the sign of the middle term. So the 6 goes there. That's the next step I make, which leaves the 2 has to go there. Now, we still haven't solved it. Keep going. We still need to solve for x.
So x would be -2 and +6.
Correct. Okay. Next one. X squared plus 18 equals 9x. What's the first thing I should do here?
Subtract 9x from the right side.
In other words, put it in a standard quadratic format, which is that, and 0 on the other side. Now we got to factor this. Again, it's x and x. What do both signs have to be?
Or
They have to be the same.
Would it be -6 and -3?
Yeah, but let's do this step by step in terms of factoring. First step was to split up the x's. Second step is to determine both signs. Well, the only way I can produce a plus 18 is if both signs are the same. They either have to be negative, negative, or positive, positive. And I look to the sign of the middle term to figure out which. Since it's a negative, then I know they have to be negative, negative. So that's my second step. Now my third step is factors of 18 that add, because of that plus sign, to the number 9. And you're right, 6 and 3 add to 9. A What's my solution?
X equals 6 and 30.
Okay. What am I going to do here? What's my first step going to be?
Foil the...
Okay. Begin
let's
to
see.
foil the left.
Okay, so it'd be 9x squared minus 3x plus 3x is 0
And then
minus 1.
minus 1. Notice what we're looking at. That is the difference of perfect squares factored. Right?
Mm-hmm.
In other words, my answer came out to be difference of perfect squares. Well, a really good skill to acquire is recognizing when you've got difference of perfect squares factored. And that's what that looks like. So I can come up with the answer. I don't have to FOIL the whole thing. I just have to square the first term and subtract the square of the second term. You see what I mean?
Mm-hmm.
All right. Right side, you got to go ahead and FOIL it. So what do we got? X squared plus 9 plus 4x is plus 13x plus 36 minus 42. Now we got x squared plus 13x minus 6. And that's equal to 9x squared minus 1. What's the next step?
Subtract x squared. Wait, yeah. So it'd be 8x squared minus 13x plus 5 equals 0.
And that must be factorable, otherwise they wouldn't have this on here. Now, there's no greatest common factor, so I can't simplify it. So I've got a couple of problems. First of all, there's a few ways to break up 8x squared. Well, it's either 8x times x or it's 4x times 2x. I always start with the two factors closest together. 4 is closer to 2 than 8 is to 1. Okay? What are both signs?
Plus and minus.
No, I can't. I wouldn't produce a plus 5 if I had plus or minus. Remember what factoring is. It is the opposite of foiling. So when you FOIL these two terms, the way you get this constant is by multiplying that term by that term. That's what produces the constant. So when you're factoring and I look at a plus 5, I know the signs have to be the same. Otherwise, I wouldn't be able to produce a plus 5. I could produce a minus 5 if they were opposite, but they've got to be the same. They either have to be minus minus or plus plus. What, in this case, do they have to be?
Minus, minus, minus.
Minus minus. That way, we'll produce a positive number here, and we'll end up with a negative middle term. Now, the nice thing about this problem is there's not very many factors of 5. It's 5 and 1. So either it's 5 and 1 or it's 1 and 5. And let's just try the first one and see what middle term that produces. What middle term does this produce using my double smiley face?
It'd be, yeah, negative 10x, then negative 4x, so negative 14.
That is not the middle term, so it can't be that. Okay, so let's try 1 on this side and 5 on the other. Well, that produces minus 22x, so that's not right either. So now my only choice is to go back and instead of 4x and 2x, let's make it 8x and x.
Okay.
Now that produces a huge middle term, so that's not right. But what if I put the 5 here and the 1 there? Now what's my middle term?
It would be negative 13x.
Ah, I got it. So that's the answer. And when I'm doing hard quadratics, and I define a hard quadratic as any quadratic that's got a number in front of the x squared other than 1. And they become basically trial and error. Notice how I did it. I just tried all the combinations I could think of until I found one that worked.
Mm-hmm.
And I found that that's the best way to do it. Now, what's my solutions?
It'd be x equals 5 over 8 and x equals 1.
Good. Very good. That was a rather difficult one. All right. Number 50. Remember how I said that cubics are 20-minute problems?
Mm-hmm.
Well, not all of them are. Turns out that there's a very small subset of cubic functions that can be done easily. And by easily, I mean by grouping. Okay?
Mm-hmm.
In order to group a cubic so that you can factor it, the conditions that have to be true are this coefficient relative to the next one, in other words, 1/3, has to be the same ratio as minus 25 to minus 75. You see where I'm getting all 4 numbers?
Yeah.
Are they the same ratio?
Yes.
That means I can group it, which means I can use solution by grouping. And here's how I'm going to group. I'm going to group these two, and then I'm going to group the other two. But notice what happens. By grouping, I mean I'm just going to put parentheses around it. What's got to go in the second set of parentheses? That's the first thing. What goes here?
The minus 70. Oh, just positive plus 75?
Positive 75. Remember what we're doing. We are not changing the original function. That's what you always want to make sure of, is that you're not changing anything. Now, the common mistake that everybody makes here is to make that minus 75 because that's what they're looking at. But notice that it's only if I make it plus 75 that it's the same expression. You with me?
Yeah.
Okay. Now, factor each thing in parentheses. What's the greatest common factor that I can take out of the left paren?
Oop, x squared.
Leaving behind?
X plus 3.
Good. What's the greatest common factor I can take out of this?
25.
Leaving behind?
3.
X plus 3.
X plus 3.
Now the secret here is that these are always the same. In other words, if a cubic qualifies for grouping, you're always going to end up with this binomial that's the same as that binomial. And now the next step is one that you have probably not taken very often. You're going to factor out a binomial. In other words, from that expression, I'm going to factor out an x plus 3. What's left behind?
X squared.
minus 25.
Minus 25.
Now, do you see why that is the same as this?
Yeah.
In other words, you're not limited to just factoring out monomial terms. There's nothing that says you can't factor out a binomial term. And that's what we did. Now, this actually factors again. So what are my three factors?
X squared.
No, this is difference of perfect squares. Factor that.
X minus 5.
Times.
X plus 5.
So now I've got three factors equals 0. What are my three answers?
X equals -3, -5, and +5.
And there you go. In other words, that only took us about 2 minutes to do. But the only reason it was easy to do was because the ratio of those two first coefficients is the same as the ratio of the last two coefficients. Whenever you find that, you can solve it by grouping. You can solve it by doing exactly what I did.
Okay.
All right.
Mm-hmm.
Let's look at the next one. Hold on a second. Let me close my office door. Notice the next one is another cubic. What is true about this cubic? In other words, whenever you see a cubic, the very first thing you should check for is, can you do it by grouping? Can you?
Yes. Wait. No.
Yeah. Let me give you a piece of advice. If you can't, they're not giving it to you.
Oh, okay. So yes.
It's beyond the realm of Algebra 2 to be able to factor cubics unless they can be done by grouping. Those are the only ones they've taught you how to do. So if it can't be grouped, you're not solving it, I'm not solving it. So the fact that it's on this test means that you should be able to do it by grouping. Well, the fact of the matter is that 4/12 equals 1/3.
Okay.
Okay, as long as the ratio of those coefficients, you see where I'm getting the 1?
Yeah.
Okay, or I could even say -1 over -3, same thing. But the ratios are the same. So now group it into two different parentheses.
So 4x cubed plus 12x squared would be 1.
What goes in the other one?
Minus x plus 3.
Good. Now treat each one on its own. Take the greatest common factor out of the left.
It'd be 4x squared.
Times.
So you have x plus 3. Minus x plus 3.
Now, what's the next line? What can I factor out of that expression?
Couldn't you do x plus 3 for both of them?
Well, I'm going to factor out an x plus 3. What is left behind?
4x squared plus x plus 3 minus.
When I say what is left behind, the way you get it is by dividing each term by your greatest common factor. Notice that that gives you 4x squared. When I divide that by x plus 3, I get 1.
Okay.
Okay. Now, again, we've got this second factor is difference of perfect squares. What's that factor into?
2x minus 1, 2x plus 1.
Good. And what are my solutions?
X equals -3, -1, and +1.
Not -1. You got to be a little careful. It's
Oh,
not always
yeah.
that. In other words, you have to set this whole thing equal to 0 and solve it. So it turns out to be 1/2.
That was 1/2, yeah.
The other one is -1/2. Okay. So I'm glad this came up because that's also a common mistake, is just to assume that it's the opposite sign of that number. And it isn't if there's a coefficient in front of the x. It never is. In other words, you could do it with that one. -3 is obvious. But what you really did was you set x plus 3 equal to 0 and solved it. That's how you got -3. You don't just take the negative of the number.
Okay.
All right. Hold on a minute. Let's see where they're going next. Imaginary numbers. Okay. Have you had imaginary numbers in class?
Yeah,
Okay.
a little bit.
They're actually not nearly as hard as they look. In other words, I'm just going to FOIL these. So FOIL that.
So it'd be 30.
I'm going to add 2i plus 10, but first I'm going to FOIL it.
Okay, so 30 plus 42i plus 20i plus 32i squared.
It's 28i.
28i squared.
Now, here's the key. If I equals the square root of -1, that's its definition, what is I squared equal to?
+1?
No? Square that. What do you get? -1.
Oh, just -1.
Yeah. So when you're doing these simplifications, whenever you run into an I squared, that's a real number. That's -1. I's are imaginary numbers, but I squareds are real numbers. So simplify this. Starting left to right, we got 30 plus how many I?
Including the +2i?
No.
On the other. Okay. Then it'd just be
42i and 20. Oh yeah, I'm sorry. There is a +2i there. Yeah. Well, what I meant was simplify that. We'll take care of that 2i and 10 in a bit. I just want to make sure you can simplify that. In other words, this is what we got when we FOILed these two things. Okay. So we've got 62i. And since I squared is -1, that becomes -28. Then we have +2i plus 10. Now, if I combine all my i's, I've got 64i. And I combine all my numbers, I got 12. So the answer is 12 plus 64i. And you always want to try to put it in this format, a plus bi. In other words, I don't want to write 64i plus 12. That's not in a plus bi format. But 12 plus 64i is. A is 12, b is 64. Both a and b are real numbers. It's just that b is the coefficient of the I term.
Okay.
Okay. So you always want the real number plus or minus a coefficient, which is a real number, times I. So that's how you multiply, add, and subtract. multiply, add, and subtract is really easy for imaginary numbers. The only thing you have to remember is that I squared is equal to -1.
Okay.
Once you do that, then you can combine everything else and you'll end up with nothing but an I, some number of I, and some number.
All right.
Now, unfortunately, I do not have enough time to cover the next two questions, or the next single question even. So let's stop at 52, and we'll pick up from 53 and cover 53 and 54. Neither one of them are hard, but they're going to take a little bit of explanation.
Okay.
So, Madison, I will talk to you next time. You don't,
All right.
my calendar's working again, so I'm okay now.